Welcome to the next lesson in this module, where we'll dive deeper into some advanced topics related to classes, interfaces, inheritance, and polymorphism in Java. After completing this lesson, you should understand what abstract classes and methods are and how they differ from concrete classes and methods. You'll also recognize how abstract classes compare and contrast with Java interfaces. In addition, you'll learn how Java supports various types of nested classes that are defined within the scope of an enclosing class. Not every Java program uses these advanced Java features, but once you are familiar with them, you'll be able to read and write more powerful apps in Android. Up to this point, we've been focusing our discussion on concrete classes, which are classes that implement all of their defined methods so that they can be instantiated directly to create and manipulate objects. The GUL class is a good example of this. It's also possible, and often quite useful in Java, to define so-called abstract classes and/or methods. These classes and methods create what we refer to as abstract types that provide an incomplete implementation, or no implementation at all, and can be used to define and enforce a protocol that must be supported by subclasses. For example, the class AbstractMap is an abstract superclass that defines certain methods that must be implemented by all map implementations, such as hashmap and treemap. An abstract method is a method that's declared without any implementation. In other words, the method signature is followed by a semicolon rather than an opening and closing brace containing the method definition. An abstract class is a class that is declared with the keyword abstract before the keyword class. An abstract class may or may not include abstract methods. For example, the abstract map abstract superclass defines the abstract entry set method. An abstract class can't be instantiated directly, but it can be extended by a subclass. If that subclass provides implementation of its abstract methods, then instances of the subclass can be created. For example, it's not possible to create an instance of AbstractMap, since its entry-set method is defined as abstract. However, it is possible to create an instance of HashMap, which extends AbstractMap and provides an implementation of entry-set. Abstract classes and abstract methods are used in many Java and Android class libraries to create inheritance hierarchies whose methods must be overridden by subclasses to transparently customize their behavior. Now that we've covered both Java interfaces and abstract classes in earlier discussions, we can compare and contrast them. Abstract classes are similar to interfaces in many respects. For example, neither can be instantiated directly, but instead must be customized, either by subclassing in the case of an abstract class, or implementing in the case of an interface. They both can contain methods declared without any implementation. However, abstract classes have additional capabilities that go beyond what's available in Java interfaces. For example, abstract classes can define fields that are not static nor final. Likewise, abstract classes can define public, protected, and private concrete methods. In contrast, interfaces can only define public, static, and final fields, and all methods must be public. Moreover, in releases of Java prior to version 8, methods in an interface cannot be implemented. Another difference between a class and an interface is that a class can only extend one class, whether or not it is abstract. Conversely, a class can implement any number of interfaces. In addition to allowing developers to create top-level classes within a package, Java also enables one or more classes to be defined within an enclosing class. Classes organized in this manner are called nested classes. For example, Java Vector is a top-level class that defines several nested classes to handle its various iterator mechanisms used to access each element in a vector without exposing details of the vector's internal implementation. Nested classes provide several benefits, including grouping together classes that are only used in one place to avoid creating additional files. For example, nesting the iter and vector splitterator classes within the vector class enables all these classes to reside within the vector.java file. Nested classes also increase encapsulation by hiding implementation classes that needn't be visible to other top-level classes. For example, the nested iter class is defined as private, so it can't be accessed by clients that use vector. Finally, nested classes enhance maintainability by placing nested classes within top-level classes, so the nested classes are defined close by to where they are used by programmers. For example, the iter nested class is used by the iterator factory method defined directly above it, and the vector splitterator class is used by the splitterator factory defined directly above it. There are two types of nested classes. An inner class is a nested class that can reference non-static methods and fields in the enclosing class. For example, iter is an inner class that can access the mcount field defined by the vector top-level class. Likewise, next method in iter can invoke the element data method defined by vector. A static class is a nested class that can't reference non-static instant methods and fields defined in the enclosing top-level class. For example, vector splitterator is a static nested class that doesn't access any fields or methods defined in vector, but instead uses fields it defined privately to maintain its own state. This lesson focused on several advanced Java features that, once mastered, will greatly enhance your ability to read and write powerful apps in Android. Now that you've completed this lesson, you should understand what abstract classes and methods are, and how they differ from concrete classes and methods. You should also recognize how abstract classes compare and contrast with Java interfaces. In addition, you should have learned how Java supports various types of nested classes that are defined within the scope of an enclosing class. Java is a large and ever-evolving development and runtime platform. Be prepared to continue expanding your knowledge of its features, both in the context of Android and beyond. In the meantime, don't let the contents of this lesson rattle you. Begin working on the programming assignment for this module if you haven't already. Review the material, apply what you have learned, and reinforce your understanding by building, breaking, fixing, and rebuilding these programs.